Now let's take a look at these integrals. These integrals are related. This integral is the one we just did, and we found this to be equal to -4/3. Let's just get a picture here. We had from 0 to 2. That's what it looked like. We were doing the area of that. That's 2. That's 0. So now we're going to go to 3, and at 3, f of x, when I plug 3 in, I'm going to get 9 minus 6, which is 3. So that's going to go up like that. So from 2 to 3, this next interval, it looks like this. So obviously that's going to be a positive shape. So let's find that next. Once again, I'm going to use right endpoints to find it. So delta x is going to be 3 minus 2 over n, or 1 over n. And for my c sub I, since I'm using right endpoints, I have to start at 2, and then I'm going to add what I jump by. And remember, what I jump by is I over n. So this will be my c sub I equation that I need to put in to my limit. So limit as n approaches infinity of the summation from I equal 1 to n of 2 plus I over n squared minus 2 times 2 plus I over n, all of that times my delta x. So I need to FOIL this and distribute this. Foiling that, I'm going to get 4 plus 4I over n plus I squared over n squared minus 4 minus 2I over n. All of that gets multiplied by 1 over n. Notice that I have a 4 and a minus 4. They cancel each other out. Becomes the limit of the sum of, putting things in order, I'm going to put I squared over n squared first. Oh, and I'm going to distribute this and combine like terms. So this would be over n cubed. And 4I minus 2I is 2I. So that becomes plus 2I over n squared. I'm going to make that become pulling that 1 over n cubed out of the sum of I squared plus 2 over n squared and the sum of I, which becomes the limit of 1 over n cubed times n plus 1 times 2n plus 1 over 6 plus 2 over n squared times n plus 1 over 2. I can do some canceling. This n makes this become squared. This becomes 2n squared plus 3n plus 1. This cancels with this, and these 2's cancel. So that becomes the limit of two n squared over 6n squared plus 3n over 6n squared plus 1 over 6n squared plus n over n plus 1 over n. This goes to 0, this goes to 0, this goes to 0, and this goes, nope, hold on. This goes to 0, this goes to 0, and this becomes 1/3 plus 1, or 4/3 from that and that. So the area of the green region is 4/3. We saw the area of the blue region was negative 4/3. So now they ask us, what if I did the integral all the way from 0 to 3? So if I included it all together, then that would be equal to the integral from 0 to 2 of x squared minus 2x dx plus the integral from 2 to 3 of x squared minus 2x dx, which is negative 4/3 plus 4/3, which is equal to 0. So with this long problem, what it illustrates for us is that we can take a whole interval and separate it into two separate integrals where c is somewhere in between those two integrals. So that's exactly what we just did. We found the integral of the left side, the integral of the right side, and we added them together to get the total integral. This theorem also says that you can take these constants that are in front and move them out in front of the integrals. We've done that before, so that's nothing new.